Hello there. This week we speak about work strategy in R and RStudio. So the learning outcomes, create and maintain readable and runnable code, debug some R errors, store objects from R sessions permanently. We'll explain what we mean by that. Run external R scripts and then handle and save plots. And this is called graphical windows. I'll explain what I mean by graphical window. So overall, this is not a heavy week of content. We're not teaching you new, coding things in terms of syntax or functions. Really, we insist on work strategy, how to best organize your work. There will be a few commands we're going to show that are probably quite useful in terms of like specific things you want to do. For example, saving your plots. But overall, it's more general tips to organize your work. So R scripts. The most important type of file, obviously, is your .r file, where you save your code, or I should say, the file in which your code is saved. So this is the code that can be run, and where, of course, the majority of your work is. I think by now you know how to create an R script and save it. Now, it's very important to maintain your R script so that they are easy to use, fix, and modify. Basically, when you start working, maybe your work is a bit drafty, but eventually you want to perfect it such that it's very neat code that you can just run as is, that is very easy to read, and then later to change if you need to change it. And so here, again, overall, those will be tips and tricks to have well-maintained R scripts. As a comment, you might think some of those advice don't really apply to making relatively small tasks that you've been doing up to now. Even if that's true, well, I'm not sure it's true, but even if it's true, eventually those tips will become very helpful for you. So maybe in second year or third year or later in your coding career, you can go back to those tips and they should help to organize your work. Okay, comments. So as you probably know, comments, well, they're almost as important as the code itself. What they are is simply whatever that follows the hashtag symbol in your R script. And so this indicates text that should be read to better understand the code, but of course it's not executed, right? So anything on a given line, anything after the hashtag is not executed by R. It's meant as a comment to help whoever's reading the code to understand the code. Sometimes raw code can be confusing, and so the purpose of the code cannot be immediately clear. And so in these situations, having comments will really help whoever's reading the code to understand it. Just a small example here. Take a moment to read the following code. It has no comments. It has no comments. It's not super complex, but there's a few steps there. And when you see this code without comments, it's going to take you a while to understand what it's doing, which is not ideal. Now, again, it's a small example. Eventually, if you read this, you'll figure out what it does. But if you just look at that, you'll have lots of questions that will take you a while to figure out by yourself. What is n? What is full? Okay, this is actually, when you think about it, it's creating the numbers in the Fibonacci sequence, but how exactly are the numbers created? What does the function return? So you see it's a function, it's going to do something, at the end it returns something. What does it return? All stuff you can figure out if you concentrate and read line by line, but it's much easier to understand what the code is doing if it's properly commented. So for example, here, that's the same code, so it's doing exactly the same thing, but with the hashtags. So creates a function that computes the Fibonacci sequence up to the nth term, inclusive. Full equals true returns the entire sequence of numbers. Full equals false only returns the nth number. Okay, so you see, just a bit of comment here, you know very well what the function is meant to do. Return either the nth number in the sequence or the full Fibonacci sequence. By the way, if you don't know, the Fibonacci sequence is this sequence of famous numbers where every number is just the sum of the previous two. Right? So it starts at 1, 1, but after that it's going to be 2. After that it's going to be 3. After that it's going to be the sum of 2 and 3, 5, and then 8, and so on. And then the comments don't stop here. Every time something is done in the code that needs a bit of explanation, you have it as a comment, right? So initiate the sequence with first two numbers 1, 1. All others are NA. Okay, that makes sense. Here we create a vector. The first two numbers are 1, and then the next numbers, there's n minus 2 of them, will be NAs. Conceptually, this will be the vector that will be filled with all the Fibonacci number that we're creating inside this function. Then you have a for loop for j in tree to n, but you have a comment explaining what's happening there. Every number in the sequence is the sum of the previous two. So every number in the sequence is the sum of the previous two. And you look at the code, okay, that makes sense. This new number in position j will be the sum of what was j minus 2 and j minus 1, the previous two. Okay, and then more comments. If argument equals true, then return the full sequence. So if full, return my sequence. Otherwise, just return the very last number. So if this argument full is false, then you will return specifically the nth number. So hopefully you see the point here. When you look at this code, not so easy to understand, but if every line is explained, much better. Okay, and this is just a bit of general explanation. When you write your code, try to imagine yourself in some other person's shoes who's trying to, who knows nothing about your code and is trying to understand it. So ask yourself whether they would be able to understand what is happening without analyzing every line of code, right? Obviously, if you just stare at this code and really concentrate, you'll be able to figure out what it does, but it's going to be, a waste of time to figure everything out compared to the case where it is nicely commented. And by the way, this hypothetical other person might just be you at some future time, right? It happens. It happened to me as well. I write a code. It's very clear to me. I don't really comment it. But then maybe weeks or even months pass, and at some point I go back to my code. I need to use it, and I forgot my reasoning. And there's no comment, so I need to redo the whole process of understanding my own code because I was naughty and did not comment it. Another tip is to have sections for your code. So in your R script, you can have stuff like this. Basically, you make it clear what every little bit or section in your code is doing. So maybe you have a section for data preparation, and then whatever this bit is doing, some visual exploration, and so on. That's a bit of a visual thing, but it really helps to then quickly remember, okay, this section is doing this section is doing this, and so on. Yeah, does not matter how you denote those sections. Okay, it could be just a whole line of hashtag, for example, but as long as it's clear. A few comments about variable naming. We mentioned a few things about that in week 1. Overall, we're just saying good practice is to have meaningful names for all your R objects. And so just a bit of an example here, but okay, here you have this vector results. Okay, that's I suppose a correct name, or it's a reasonable name. It's just a vector of here you can assume those are students' results. So the first students passed, the second failed, and so on. But then here, this name fails is maybe not ideal. You can look at the code. What it's doing is just summing how many results here were fail. So it's counting how many students failed. But why not have a more descriptive name than fails? Something like number of fails is much better, because then you know, okay, it's exactly this, the number of people who failed. Well, fails is a bit too vague. It can be something else. Like a list of, maybe it's a list of students, you don't know, right? You want to know exactly what it is. And maybe having well-named variables means you need fewer comments because then you don't really need a line of comment to say what this is, or the number of fails is pretty self-explanatory. A bit of a minor point, but maybe try to be consistent in how you name your variables. So number of fails would be fine. Number dot of fails, maybe you want to use lowercase and then uppercase, something like that. But then if you pick the underscore to be your favorite kind of convention for names, keep underscore everywhere. It's a bit neater. But that point, I suppose, is a bit minor. Next, indenting code. So again, it's a stylistic point, but it does make the code much neater and also easier to debug if there's mistakes in the code, right? If there's indentation. So the core idea is simply that indentation should make clear to the reader of the code which lines belong to what branch of the code. And the rule of thumb is that whenever you open a new set of braces, so that would be one branch of the code. And so any code in between the open and closed braces should be indented, meaning you can use the tab key to make a big space, pushing it to the right of your R script. Now, RStudio does do this partially for you, but when you have many of those things, it doesn't always work like nicely automatically. Now, let's just review an example, and maybe it's a bit unclear what I mean by indentation. This code is indented, right? This one is not. You see, it always starts, the first line of code is always aligned, but that's bad practice because here, this code is relatively complicated because you have a for loop, and inside the for loop, you have another for loop. And then inside this for loop, you have an if, right? So it's better to indent every new thing, basically, right? So, or every new branch. So this bit is harder to follow than this bit, right? And again, the tip is here, I'm opening a new branch, so I'm gonna start a space more to the right of the first line. And then 4 is fine, but then I open a new branch, I'm going to start it here. Here, I open a new branch, I'm going to start it here with one more space, and so on. And it makes the code more readable, and also you kind of, it's easier to keep track of which branch is open and which branch is not open, right? This one, okay, you see, this one is the first to open, it's going to be the last to close, and then this one is the second to open, it's going to close here, and so on. This one opens here, it closes here, this one opens here, it closes here. Here, it's kind of tougher to see what's going on. And maybe I can show you, I think this point is made later, but let me show you in RStudio that RStudio actually highlights a brace when it's open or closed, so to help you keep track as well. So let me just show you, I have an empty my R script here. So if I copy paste, whoops, I want to copy paste here in my script. You see this, let's say that I delete it, or you see when I create it, it's going to highlight the last one. Right, it's going to highlight this one. Same thing here. When I click, you see it's opening here, closing there. This one is opening, well, closing here, opening here. RStudio helps you a little bit with this. And then maybe I can move on. Now this is a point about keeping backups. So as your projects become larger and more complicated, the probability that you make a big mistake somewhere, or you damage your code in some meaningful way increases. And maybe you can mess up something that will make you, will make fixing the mistake very hard. If you have backups of different versions of your code at different points in time, then maybe you won't have wasted or lost too much meaningful work. So the point here is just to have many versions of your code as you progress that you save somewhere in a folder. Maybe you call this older versions. And if you ever need to go back to older version, your code is going to be there. And also, it sometimes happens that you progress your code, and along the task you're doing, you delete a part of your code that is no longer useful for this specific task. But later, you actually realize, that code was actually useful in itself to do something else. But if you've deleted it, well, it's lost, right? Well, if you've kept an older version in code v2 or whatever, you're like, yeah, this piece of code, this precious piece of code I now need for another purpose, I can find it again in v2, for example. And by the way, those backups, yeah, you can call them v1, v2, but I personally give them meaningful names, right? I might say, okay, code version, I don't know, before I something, right? Before I vectorize all my functions, something like that. I might have very long names, which is a bit ugly, but then it's going to be way more meaningful when I try to remember what each version is doing than being called v1. I mean, obviously, you can just have a header in your code that describes exactly what this code does, so it doesn't have to be in the name. But somehow keep a record of, okay, version 1 is doing this, version 2 is different because it's doing this. If it's not in the name of the file itself, it can be in a header of the script. Okay, obviously sometimes, or these days, you often store your stuff in cloud storage. They have their own way to restore old code, but it's not perfect, right? I think it saves it at kind of random times. What is probably better is if you yourself save it at significant points in time, right? When you make or when you're about to make a big change in your code, then you save the old version without the before the big change is made, and then you keep going. This way, all those versions are very meaningful. They're not just saved at random points. Okay, and you can also use Git to do this, but this is not really something we're going to address in this course. Okay, now this is a point about maintaining runnable scripts. Runnable scripts. It should really be that your R script, like a file such as this one, you can run the entire thing and it doesn't generate errors, right? Now, this might sound like a trivial point. Why am I even making it? But in reality, and I suppose I'm guilty of this myself, I think it's quite common for people to be a little bit lazy and just have a big script where they just add a bunch of stuff, and some of it works, but some stuff in this script is old and actually doesn't work, but they don't delete it or they don't bother saving it elsewhere as an old version. They just have lots and lots and lots of code blocks that they kind of know which one works, which one doesn't, and maybe they're actually not in the proper order, but they have in their mind this sort of mysterious order in which those blocks of code should be executed, and they don't basically bother to have a code that is runnable from top to bottom. This is bad practice. Now, it might work, especially for small tasks like an assignment or something like that in first year, but eventually you'll get to make bigger projects in uni and then outside in when you start working, and I mean working to earn money. And then it's really bad practice to have a big code file that does a whole bunch of things, but it's not. It's only the user who knows what piece does what in what order. So anyway, hopefully I've convinced you this is bad practice to have just one file that does everything. It makes it very difficult for anyone else to understand your code. Well, often in real life, you're going to share your code with other people that are going to maybe use it or rework it. So it needs to be clear for them what the code does. And then obviously when something goes wrong, it's going to be harder to isolate the mistake if your code is kind of all over the place and different sections actually run, but individually, not as a whole thing. Okay, hopefully I'm not rambling too much here, but just two general principles to follow to kind of avoid having unrunnable scripts. If you are completing multiple independent tasks, maybe as part of a larger project, it's good practice to have the independent tasks in different R scripts, right? This R script achieves exactly this task, or this part of the project. Now another R script achieves another part of the project, and so on. You have different R scripts for different subtasks within a big project. Yeah, so more independent files with clear divided purposes makes your code easier to understand. Again, this is maybe a bit abstract, but for a big project, you could have kind of a master file, a master R script that calls all the other R scripts, right? And that's possible. You can have one R script that executes everything that is in a different R script, and that's a good way to organize your work. And I'll explain that exactly what I mean in a few slides. A R script that executes everything in a separate R script. And the other point is, always make sure you can run the whole script. Otherwise, something's wrong, right? Something's wrong. So you should be able to, in RStudio, go here, have a clear environment, like you scrap everything, your environment is clear, so you can clip the broom here. And then you should be able to run your code. So click run, and everything executes without errors. If there's error somewhere, well, you need to fix them. Errors. Okay, so if you run your R script all the way through and you find that R reports an error, well, you now have the mission to find what's going on, where the error occurred and why it occurred, and of course, fixing it. Now, R usually will give you some error message. It's not always the most useful, but please do read the error message and start from there. What is R telling you the problem is? Do you understand what the problem is? If not, well, you need to do more digging to fix it. Usually it's best to run little bits of code one at a time. And so you run the first bit, the second bit, no error, the third bit, no error, the fourth bit, there's an error. So then you know the error is, of course, in the fourth bit. And of course, to run code line by line or a little chunk at a time, you can use Control Enter, right? Just to show you in R. If I run this whole thing, okay, I get all my results. But if I just want to run this line, I can select it and run Control Enter. But here, probably I'm going to get a mistake because no, okay, so R tells me nothing happened because I just opened the for loop, but I didn't do anything else, so nothing happened there, I suppose. Yeah, I think okay, yeah, plus means that R is expecting something else. Like R knows that the code is not over. Actually, R, it's interesting, R auto completed the for loop with closing the bracket, even though I didn't. If I type Control Enter, okay. Now it did what I expected. You see it literally just run this line. Just run this line, and I have the plus. Plus means an R that R is telling me, okay, something's missing. You haven't finished this. So you see, I haven't gotten an error because R tells me, okay, you need to keep going. Like you opened the for loop, but you didn't close it. But now if I type whatever, if I type just one, I'm pretty sure I'm gonna get a mistake. Will I? I'm not sure. One. No, I get plus again. Okay, I get plus again. Eventually, if I close it, you see I don't get a plus because now R understands, okay, this has closed. Now, obviously, I haven't done anything in this code, right? But I'm just explaining you the meaning of this plus thing. Plus thing. Okay, now there's no magical solution to resolve errors, right? If you get an error message, you will have to figure out why is that, and there's no magical trick. Here we give kind of some global tips and I suppose common simple things that you might have forgotten and creates an error. Now the first thing is read and try to understand the error message, right? Sometimes it's a bit hard to understand what it means, but don't totally ignore it. Try to make an effort at understanding what the error is. And sometimes the error is not so clear, but maybe you can Google it and then somebody is going to explain to you, okay, this error is actually, this is the actual explanation of the error, because R will give you like a very short explanation. Okay, check you have spelled all the variables and functions name correctly. Yeah, very common that you forget the S or you forget something in the name of the variable. Then of course you're going to get an error because the variable doesn't exist. Like for example, here if I type, well, I can type anything because no variables well, have been created, right? If I type my object, well, this is just a random name, it doesn't exist. Error, my object is not found, right? Well, in this case, it's very clear to understand what this error says. Obviously, my object doesn't exist. Okay, very, very common mistakes is to mess up the brackets, right? Those brackets are for the arguments within a function, right? While those are usually for chunks of code, like for loop and else if and so on, right? Now you might have opened it but forgot to close it, or you might have used this when you should use this. So this is a pretty common mistake. Okay, I showed you before, but RStudio highlights the matching brackets for you, which can be helpful. Again, what I mean is just this. You see, I click this one. RStudio tells me, okay, it's closing here. Check that all the variables are using you are using R of the right type. So yeah, having a variable of the wrong type is a common mistake. For example, this supposes that other vec is a number because it's comparing it, to the number 3. So of course, you need to double check other vec is actually numeric. And as we've mentioned before, you have the help page that gives you usually quite useful information about specific functions, right? So we mentioned this before, but if you type a $ and then the name of a function, whatever, apply, I'm going to get here in the help panel the basic information about the function apply. Or you can search it here directly, R norm, and etc. And then obviously Google can be your friend. Very often you'll find a resolved specific error on Stack Overflow, for example. Or if it's not exactly your problem, it might be very close to your own problem that you can then resolve it yourself. Now, all of that is a bit blah, 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 but I suppose it takes a bit of practice to get the hang of how to solve errors. Might be quite frustrating at first, but I have faith that with time, you will mature as a coder and become more proficient at solving errors effectively. Okay, now we get to a part that is not so much, well, it's still part of work strategy, but it's a specific thing I need to tell you and teach you how to do. It's storing your results permanently. Now, the point here is when you create variables or any R objects, they are only stored temporarily in your R workspace, also known as environment. When you close your R session, the variables are lost. They are lost. So, for example, here we already made the point that this thing, my object, doesn't exist, but I could create it. I could say, okay, my object is going to be whatever, a random sequence of, let's have exponential distribution for a change. Okay, 1,000 of them. Okay, now my object exists. So you see it here on the right. My object is a sequence of those random numbers. I could type head and get the first few numbers in my object. But the point is, if I close my script, or no, I'm not going to save, don't save. Actually, this is something else I wanted to show you, but I'm going to just close RStudio entirely, right? So I'm not going to save. But now I'm going to go back to my script. So I'm opening RStudio again. My object and everything else will have had disappeared. Let's just wait a second and then sip while we wait. Well, I'm going to sip from my Mr. Happy mug. You do what you want with this little pause. Okay, so you see now my environment is totally empty. So obviously I've closed RStudio. My object from before has disappeared. The point here is you can save your environment. So you can save all the objects you've already created and to reuse them later if that's useful. So now doing that maybe might not be so useful in this course. I don't know. We're doing small tasks that usually your code runs instantly or almost instantly. So if you lose your objects, it's no problem. You can rerun your code that created those objects and you get them again. But the point is that with larger projects, some code sometimes takes a very long time to run, maybe hours or even days sometimes. And this code creates some objects that you need for some purpose, like it creates, let's say, a huge data set. And again, imagine it takes hours to create this data set. Well, you don't want to recreate it each time. You want to pick it up from where you last created it. So because of that, you want to store this data set, for example, for the later time, right? So how to do this is what we explain next. But what you're going to save now is something with, it's a file with the extension .rdata. So .rdata is saving the actual objects in your R session as opposed to saving your R script. Okay, as opposed to saving your R script, which you already know how to do. Now, how to store those objects or results permanently is very simple. You can use directly from your console the command save.image. So save.image, and inside the brackets you put the path where you want to save. So this you can put whatever folder you want to save your objects, and then the name you want to give to those R objects with the extension .rdata. There's other ways you can do that. So you can go, like, this is a bit manual, but you go to session, save workspace as, and then you're going to find, well, you can save wherever you want. So let me just show you. You go to session, save workspace. So now you would save your workspace, and then you're going to pick a file on your computer to, well, wherever you want to save. So you see, maybe I can show you that it works. So here I have nothing in my environment, right? But let's declare again my object. Again, I'm just going to generate our uniform this time of size, I don't know, 1,000,000. That should be fine. Okay, so now this object exists, but now I'm going to save it. Now, I'll just save it in my working directory. Now, I don't know where my working directory is, but let's find it. So I remind you that get working directory will tell you where R is currently looking. So now R is looking at this. For me, it's a folder called R demos. Okay, it's a good place to save my object or everything that's here in the environment. So let's do that. The command was save.image. And then I'm just going to give it a name. Well, my image or my R image, which is a random name. and dot, remember this was R data. That should work. And you see, I'm not specifying a whole path because this will just save to my working directory. It will just save to my working directory, which in my case is this folder. Okay, let's see if that works. Okay, it works, or at least it looks like it did. To show you that it worked, I'm going to close this. I'm not going to save anything. Don't save. And then you see, I'm going to go. This is where my stuff is. So if and then I can, so then the point is I can load it. Okay, I can load it. I think it should work if I just click on it. So my R image is just what I saved. Note it's obviously separate from my R script. My R script is where my code is. This is where my R objects are. So if I open this, should probably work manually. Again, it's sipping time for me. Okay, this is what I was saying. I clicked on it. It's going to load it. That's fine, but you can also use the command load to do it. So let's try both ways. So here, yes. So I want to load this in my global environment, and you see now it's my old script, but my object is now there. It's there because I saved it and I just opened it. But now let me close this again and show you the don't save. Show you the other way. So if now if I open my main R script, which again is just an R script, but it's empty, my object won't be there because I haven't loaded it yet. Again, please bear with me. I don't know why RStudio is slow today. It's always slow when I need to record a video. Okay, here we are. So you see, environment is empty. The environment is empty, but I can load any environment I want. And by environment, I mean just a collection of R objects. By using the command load. Okay, so load. Copy paste this in RStudio. Now, my name was again my what was it? My R image. And this should work. Now it should work because hopefully my working directory is still where my file is. Yes. So load, and voila, my objects I can now use it. And you see, this might sound useless for you because you've been doing only small things. I don't want to insult you, right? But the point here is, imagine my object is a huge database that takes hours to generate. I want to be able to load it quickly, right? Not regenerate it with a bunch of R codes each time. Hopefully that's kind of clear. Okay, you can also load it manually by going to a session and load the workspace, or by clicking on the specific file, as I just did before. You know, when I clicked this, my R image. Now, some key points to keep in mind. The second method for loading, so this one where you go to a session and you click, does not abide by the strategy of maintaining fully runnable R code. Yes, because by fully runnable, we would mean you can just run your code. You don't have the manual task of clicking something. I'm not saying never do that, but I suppose it's slightly better to save it like that, right? With the line of code rather than the manual selection. But I'm not going to be too pedantic about that, I suppose. Hopefully this point is clear, but the instructions above are to save your workspace. Okay, save all the objects produced by your script, variables and databases and things like that, right? Or data frames, I should say. Obviously, it's not the same thing as saving your actual R script. When you save your R script, it means you would save this actual code, okay? My wonderful code here. Saving this just means I'm saving this file that contains the lines of code. By clicking just here, about this, it's a file that already exists, so I've just updated it now. Or you can go to File, Save As somewhere, and blah blah blah, like you do with any file. Okay, this I've covered it. If you set your working directory appropriately, well, you don't have to specify a long path. You can just use my project or whatever the name of your what you want to save is, or you want to give it to. Okay, this is what I've done before. I just use save image and I just type my R image. I didn't type the long path. And what this does again is saving the image in my working directory. Lastly, if you load your R image, this R .r data file, in your current R session, any objects defined in your temporary workspace will be overwritten. Overwritten if there is an object of the same name in the loaded workspace. So careful with that. Maybe I can give you an example here. Yeah, so you see my object here is loaded. Let's say that I use the broom, so I delete it. Yeah, I'm sure I'm going to delete everything. Now, let's say I create something called my object, but it's not going to be a vector. It's just going to be a single number, right? Let's just say that my object is pi, right? Now, I just created my object. Okay, and it's the value of pi. But now let's say I load my R image. Well, my R image contains an object called my object that is a big vector of a million observations. If I do that, my object that I just created that was pi has been erased. Okay, it's been erased because I've loaded something with the same name. So just be careful about that. Okay, moving on. That's just an example, but I've covered all of that. Where I would set my working directory, I can do that manually if I'm not happy with my current working directory. And then I save image. This will save the entire R environment in the working directory I've specified here. Okay, just a bit of repeating common advice about working directories. While using working directories is convenient because we can specify shorter paths. For example, my project.rdata instead of like a whole long path, and at the end I put my object.rdata. It's also important for the sake of reproducibility. What we mean by that is if you work out of your working directory, then somebody else can just do exactly the same steps, like execute the same codes by putting at the header of the code what their working directory is, and then that's it. That's the only change they need to make, right? Then everything is going to be working as it does in your session, where your working directory is whatever you specified. Hopefully, I'm being relatively clear by what I mean here. And this is what it said here. Yeah, that's more or less what I said. And I think it's clear by now, but let me just repeat what I mean by working directory. It's just where R is looking for files, right? Right now, my working directory is this folder on my computer, and so I can just type the name of any script I want to call, or if I had a database here, I would just load it with the name of the database because R is looking in my working directory. Somebody else might want to run my same codes. They will have a different working directory, but that's all fine. They will set their working directory to whatever path on their computer they're working from, and then everything will work. Okay, calling an external R script. And this, I started, well, I alluded to this before, but you can read and execute the contents of a given R script, so a file with the extension .r, in another R script. And I'll try to explain why this would be useful. You do that with the source function. And actually, I think it's all better if I explain with an example. So I'm going to go here, and you see this is the file that's called my main R script. It has basically nothing here. I'm going to delete everything. Let's say I want to use a specific function that I created. Okay, so I created the function, and this is the same function you need to use for your assignment, at least in 2025. And it's a function called debasig. Now, basig here. Now, this function has 4 arguments. I'll try to remember their order, but the first one is x, and then it should be p, and then it should be b, and then it should be p. I think I messed up. I think the first one is q0. Let's see, I'll correct later if I need to. I'm just giving random numbers. Now, this is a custom function I created. If I execute this code, will it work? Well, kind of obviously not. The function doesn't exist in my current R script. Now, I've created this function. I tell you, it's located in this file, my functions. So what I can do is load this file, and this is where I use this command source. So if I type source my functions, what this I need to put the extension .r. Now let me just show you on my in my folder. My functions is here. It's in the same folder as my main R script, and this is currently my working directory. So because of that, this should work. I'll execute this line, source my functions.r. Okay, this doesn't do much, or it doesn't seem that it did much, but you see on the right, now the function debasig exists. And so I can then execute this one. It should work. I type this, I get the value. Okay, this doesn't really matter, but it's a priority mass function. So I evaluate it at the value x equals 10 with those parameters. And you see it worked, even though in this R script, I never defined the function. I never defined the function, but the function is defined in this code. And I've called using the function source this code. So when I type source here, the name of the R script, and I run this line, when I run this line, it executes everything in that specific R script. So calling this is really like running the entire R script. Now I can show you this has nothing else, right? This R script has nothing else, but it could be a file. So nothing else than this function. I don't know what I did here. I closed the file for some reason. I showed it in a new window. Yeah, that's not what I wanted. I'm going to open it again. My functions here. But I was just saying, you could have lots and lots and lots and lots of functions there. Maybe you put all the functions for a given task, like a given assignment, in one folder, and that's it. Sorry, not one file, one R script, and then you have another script that calls those functions and solves the assignments, for example. Maybe for your assignment, you don't really need two scripts, but actually, I'll show you why this could be useful in an example using my work, but I actually do this methodology of having all the functions that are needed to solve your assignment. I have them in one file, but I have another file, I have another R script that calls those functions to create one sample solution. And then I have another file. Let me show you, actually. I need to be very careful here not to open those files and show you the solutions to the assignment, but let's try to illustrate what I'm saying here. So I'm going to go, this is my folder with all the, I hope that nothing is secret here, but all the folders for the course. And if I go to your assessments here, now I'm actually a bit nervous. I'm going to show you stuff I shouldn't, but nah, it's all fine. The assignment. So you see, this file here, I'm not gonna open it. Don't think about it. This contains all the functions that I need to solve your assignment, right? But now I have this other R script that generates one report for like the equivalent of solving an assignment for one specific student. But you all have different numerical values for your assignment, right? So different students will get different numerical results. So then I have another file. You see, generate all answers. So this is an R script that creates all the numerical answers for all the students in the course. It creates like a database or a data frame with one line per student, right? With all the answers. But you see, both those files, generate all answers and assignment sample, they both use the functions there. And that's useful because then I don't need to copy paste those functions in two files. All the functions are there, but I'm using them in this script and I'm using the same function in this script. And that's good practice because if I'm changing the functions, like I realize there's a more efficient way to do the task, or I realize I actually made a mistake myself, how embarrassing, I need to change the functions only once because they're all in this file, this R script I call functions, right? I don't need, imagine the functions are duplicated here and here. Well, I would need to manually change all of them if I've made a mistake somewhere. You see the potential usefulness of having all your functions in one script. Okay, I think I've said too much about this already. And I'll go back to my slides. Okay, you can also execute in a given R script everything that is in another R script by using the function file .choose, but that's also manual. That's also clicking, which is worse practice than having a line of code like source that does it for you. Okay, and this is what I explained. One possible utilization of this is to call custom functions which are stored in a different R script. And again, the usefulness of that is if your functions, you use them and reuse them and reuse them in different separate tasks. Like for me, creating one assignment for one student and creating one shot the numerical results for all students. Okay, different topic. Opening, closing, and saving plots. So in RStudio, when you create a plot, it displays by default in the tab called plots. Next to files and packages, I can show you right now. And there's just a note here that if you've created many plots, you can navigate from one to the other using the arrows. So let's illustrate that, of course, in RStudio. So I'll go back to my main R script because this file is for functions only. Okay, so let's say here that I'm going to create a plot. Like let's just have a super basic plot. The x will be on the x-axis will be just the number from 1 to 10, and on the y-axis will be whatever, will be the numbers 1 to 10 but squared, right? So this, if I execute this, is going to create a plot, a scatter plot of 10 values for x matched to 10 values for y. You see by default it goes here in this tab called plots, and I see my plot. To illustrate the other comment, which is that you can create many plots and they're not lost. So if I create another plot, and you see this one, maybe I give it a title using main, x versus x squared, or whatever, x cubed in this case. Let's give it a color. It doesn't really matter, right? But since we're here, right, brown 2 for a change. I usually use brown 3, but I feel a bit different today, so let's use brown 3, brown 2. So okay, I execute this. You see, it's like a different plot. I can go back to this one, right? Or I can navigate between all of them. Okay, simple enough. Now there's another thing you can do, which is this thing called graphical window. Now, to be honest with you, I never use that, but still, let me present what this does. You can open this thing called a graphical window. Now I'm on Windows, so I'm going to use the command Windows. In Mac, apparently it's Quartz, and in Linux it's X11. Okay. So let me just show you. Actually, I'm going to read this. Once open, any new plot will be created in that window, which exists outside RStudio, and it's more interactive. And also you can have many graphical windows open at once. So let me just show you. I'm going to type this Windows. Now it's open, this window that hopefully you see. I hope the share screen works for this. So you should see this graphical window that has nothing. It's empty because I haven't created a plot yet. But now imagine, well, not imagine, but I'm going to create another plot. Like, let's make it, again, slightly different. So I'm going to have here and maybe a different type of points, maybe this one, and a different color, whatever, purple. Okay, now if I create this plot, because I have a graphical window open, it should create it in the graphical window. So let's double check. Yeah, I go back to this window and you see that's the new plot I just created, right? Where it's, I didn't change the title, but this is now x to the power 4 on the y-axis, and you see it's purple. Now I said in the slides it's a bit more interactive. Well, yeah, you can move it around, but also you can and honestly, maybe that might be the advantage of using this. You can reshape it, right? So if for some reason you want it to be very wide and not very tall, you can do that. And when you save it, so if you go here, File, Save As, you can actually save this plot, and it's going to look like it's looking in the graphical window, which maybe is an advantage. And also you can have many of them at the same time, right? So if I open another Windows, okay, now I have many windows, and I can generate a new plot. For the fun of it, now I'm gonna go crazy. I'm gonna go power 7. Okay, so power 7, and I'm gonna use another color, maybe light golden rod. Why not? Why not? And then I'm gonna make the points bigger by this thing. I think it's brown 6, but not entirely sure. And then you see now I have my other window here, but I have the other one, right? So again, this is just a bit more interactive. If for whatever reason you want to compare your plots in the same, you can. Okay, I have the two plots, one next to the other, and again, I can reshape them if I want. Okay, that is this thing called Windows. Going back to my slides. To close a graphical window, use dev off. Yes, indeed, dev off, and device number. So let's just try dev off. I go to my RStudio. This one is called device 4 for some reason. Now, if I type dev off 4, it should work, should close it. Okay. I'm going to execute this, and indeed, it doesn't exist anymore. This is dev 5. Now, you might say, why do you need this? You can just use the X. Indeed, I can just use the X. I think there's something going on that if I use the X, if I just close it like that, somehow it can still be active somewhere in the background. To be honest with you, I don't know exactly what's the difference of using this. I think if you use this, it's closed like forever. I think right now it still exists somewhere, but I'm not 100% sure. Anyway, what you probably want to do is save a plot, right? You save a plot, you put it in your assignment or a project or something. There's a few ways to do that. So if the plot is displayed in the tab plots, then you can click export. So let me just show you. You go here, this is the current plot. I can go back to the previous ones I had. But you see, I have only two here. The ones I created in my graphical window, they are not there. They are not there. But let's say I want to save this one. I could just go export, can save as an image, or I can save as a PDF. Let's say I choose save as a PDF. And here, there's a few options. You can choose where you want to save it. You choose the file name, and you can reshape it. So you see, you can still give it the size you want. For some reason, it's in inches, I guess because it's an American software. But if I want it to be like, I don't know, let's not be too extreme, but 10 times 2 just to show you it's going to look a bit weird. Oh, I don't know why it's changing. Ah, interesting. Maybe it's interesting. It's changing by default. If I put 4, it works. So, okay, I'm learning in real time that there's a limit to how narrow an image can be. Let me try again, 2. What the? No, it goes back to, I don't know. Let me see what happened there. So you see, it should save. It should save in my working directory. But again, here we're practicing our concept. Where is my working directory? It should be this R demo thing. Yes, indeed, R demo. So let's see if it saved an image. R demo somewhere. Yes, you see, I didn't change the name, so now I'm going to get my R plot. So I'm going to open it, and you see, yes, indeed, it's very wide and kind of narrow. But now I'm still curious, did it work? Because it looked like it was changing the size by default. So let me try again. Export. And those numbers, I believe, are those as you see them in the plot. But again, I want 10, and let's make it even narrower. Let's make it 1 inch high. You see, it changes it by default. It's very strange. If I type enter, though, let me see. If I type enter, okay, now it's a different one I just created. Let's see if it's narrower. No, okay, so it looks like it's because it's the same image, right? It's not narrower. So again, I'm learning in real time that the way I understand his behavior is that, yeah, exactly the same image, or is it slightly different? I can't tell you. So anyway, it looks like there's a minimum narrowness an image can have, or at least that's how I interpret what just happened there. But let me just show you. Let me just show you that it should work if I type whatever 10 by 10, then I should have a square image, right? Yeah, this looks to be fine. It's going to be our plot number 02. Go here. Let's just check. And you see now it's a square, right? 10 by 10 inches. Okay, so that's how you save whatever you see in your R plot tab. Okay, this I said, but if you have a graphical window open, you can use File and Save As. Okay, maybe let's just do it again, just to show you. I don't want to be accused of not doing my job and not showing you everything. Okay, again, I'm going to create a plot. And let's just try or test what I said before. let's imagine I make it very narrow on purpose, and now I save it like that. File, save as, let's say PDF or PNG. Why not? Why not? And then, okay, it looks okay. I'm gonna save it here. File name, test of narrowness. Why not? And here I go in my R demo. Test of narrowness should be quite narrow. See, it's as narrow as it was in the R graphical window, I believe. Okay, so that seems to be all good. Is there anything else said on the slides? Yes, indeed. You can save. So all of that was quite manual, right? You need to click save or click export. You can actually save with a line of code, okay? And that's quite useful, especially if you have a script that creates lots and lots of plots and you want to update them all one shot. You don't have to save them manually each time and choose the size manually each time. That can be cumbersome. So you can do that kind of one shot with a piece of code. So here, this is to save as a PDF, but you have the same commands for PNG and JPEG. I think there's other formats you can Google. Sorry about that. I don't know them by memory. But you see, PDF, name of the file. This will save a file named whatever this is, and you can specify the width and the height automatically. And again, this is in inches for some reason. Okay, but now this kind of initiates the plot. Whatever follows is going to create the plot, but at the end you need to close it. You need to close it and then it'll save, right? So let's just try this in RStudio. This will generate the histogram of 100 uniforms. Let's try in RStudio. I'm just going to copy paste this directly to console. I'm going to make it size 10,000. I prefer 10,000. And example 1.2, I don't know why, but that's just the name we're going to give it. Execute. And then this should have created a file called this with a histogram of 10,000 random uniforms. Let's go to my R demo folder. Example 1.2 is here. And yes, I have my histogram, which is all good. I believe that's enough for saving plots. Oh, and now we have this slide about generative AI. So as you are no doubt aware, generative AI, artificial intelligence, is pretty good now at writing code, at least for kind of very targeted tasks. The point we're making in this slide is we're not telling you to not use AI to assist you, okay, keyword assist you in writing code, but you should not take shortcuts. You should not take shortcuts. You must always make sure you understand a piece of code that an AI has created. And this is especially important for our beginners. If AI is always your crutch, that everything you have to do, you ask AI, looks good, that's it, I'm going to submit that, or well, you're not really learning to code. You're maybe learning some code, you're learning how to give good prompts to AI and generate the result that looks good, but you're not really learning. And I know you're very busy, you have lots of assignments, lots of different courses, but I want to send a message here. Yes, it may be tedious. Yes, you might feel it's a bit useless to double check everything, especially if the results look good. But please, you must go over the AI generated code line by line, and you must make sure you understand each element. Like, do I understand everything that was produced by the AI? And evaluate it with a critical eye as well. Because at least for now, there's still errors there. There's still errors, or sometimes AI do something, but in an inefficient way that is a much better way to do. And in the end, you're gonna deliver a product, right? If you don't understand the product you've delivered, and there's a problem, it's still on you. And honestly, I think it looks worse for you. Imagine you're in the workplace, right? You're working, and okay, there's an error in your code, but it's worse if it's an error that AI made and that you didn't pick up because you actually don't understand what AI did. Then it's an honest mistake you made that you can then own and say, okay, I made a mistake because of that. I think it looks worse if somebody found out you actually don't understand your code, right? And hence you couldn't pick up the mistake. Anyway, I don't want to be too patronizing here, but I do want to send the message there's no shortcut, right? It can be helpful. I can definitely help you to understand or to learn new things, and maybe some syntax can be very, very tedious to figure out by yourself. It's okay to use it, I would say, but you need to understand the final product. And obviously, a good heuristic is, to test if you've not taken a shortcut. Would you be confident to explain the code really line by line to somebody else, like your boss, for example? And if the answer is no, well, you need to go back to the code and understand what it does. And obviously, as a lecturer, I need to tell you, for university assignments, it's still possible to be caught of guilty of plagiarism, right? If you don't quote your AI use. So always acknowledge in detail how you use AI to solve a task, especially as required by your lecturer. If you use AI, you need to quote it, and you need to follow the UNSW guideline here. Okay, that's already the end of the video. There's a relatively simple exercise at the end to, I think, debug some pieces of code. So I'll stop here. Hope you took something of value here. And obviously, as usual, let me know if maybe something is unclear or I can help with something. Yeah, so for now, I'll say bye-bye. Hope to see you soon.